So today we're going to be fitting a trend line and forecasting. And forecasting is trying to predict the future. Example 1 says fit a trend line to the data in the following table, which shows the number of government schools in Victoria over the period of 1981 to 92, and interpret the slope. So because the year is actually labelled as 1, 2, 3, so 1981, 82, 83, so it's in order, what we can do is we can just number them, and we should just number them, okay, as 1, 2, 3, all the way. And then we just put in that, the number, the actual number, in our other one. We can do our scatter plot, we can get our regression line, then we can do our least squares line. So, I've already prepared this on the computer. So there it is there on the calculator. So I'm going to go and create a scatter plot. Of course, I'm going to have the year here, and I will have here there is number. So I can join my dots up, and from there I can actually get my regression line. So there we go. So I'm going to come back here. So this is the regression line. I've got number of schools, number of schools, 2169 minus 12.5 times the year. Now they want us to interpret the slope. So there's my slope, negative 12.5, which means that as the years are increasing, the gradient, or the number, in this case the gradient stands for the number of schools, is decreasing by 12.5. So on average, as the year increases by 1 year, the number of schools decrease by 12.5 schools per year. So that's what's actually happening in this case. Part B says how many government schools do we predict for Victoria in 2015? So we need to go from 81 to 2015. Now that means we're looking at 35 years. So we're going to have the number of schools. There is 2169 minus 12.5, and we're going to times it by 35 because it takes 35 years. And when we work that out, it's actually going to give us 1,732 schools. Taking seasonality into account. So when the data shows, that's what exhibit means, shows some seasonality, it's a good idea to deseasonalize the data before fitting the trend line. So example 2 says the deseasonalized quarterly sales data from Mickey's shop is shown below. Fit a trend line and interpret the slope. So that's it there, that's done, but I am going to come back to the computer. I've already got the data in here, quarter and sales. I've already labelled the quarter, so I'm going to go menu, home, sorry, not menu, scatter plot. I've got in this one here, because it was quarter and sales, quarter is the X and sales is the Y, and I am going to, I can plot, do my XY, and then I can actually analyse and do my regression. And there's my regression there. So I'll come back to the Word document. So this one will equal sales equals 838.0, and that was plus 32.1 times the quarter. Now forecasting is trying to think ahead. It says what sales do we shop in the winter of year 4. Now we've already got 3 years here. Remember there's 1 year, 2 years, 3 years there. Now winter, if you remember the order, winter is the 3rd quarter. So we're looking at, how many quarters are there? We're looking at 15 quarters. Winter was that section right there. So we're just going to put that in. We're going to go sales equals 838, remember that's a pointer there, 0.0 plus 32.1 times 15. When we do that, we get 1319.5. Now this is deseasonalised. Okay, we want seasonalised. So to do seasonalised for year 4, so year 4, seasonalised, what we're going to do is we're going to get this 1319.5 and we're going to times by the seasonal index for winter. And if you go back up, seasonal index for winter is 1.30. When I work that out, I get 1,715. So that's what I expect to get in season year 4 of this winter.